Oh, hello there. My name is Pete. Normally we're doing an EAA session with my 8-inch Schmidt Cassegrain, the CPC 800. But what I'm doing is quite a short thing today, is I'm just testing out the script I wrote for AstroPlanner. So AstroPlanner is a piece of software down here that I use to plan my software. It's very good. This is the beta version. And I put in a load of objects which I wanted to observe tonight, and I've been going through the list. But I wrote a script, and the script queries the JPL Horizons web API and brings back the exact coordinate of the asteroid that I want to observe. Because my idea is that I could take a picture, come back in an hour's time, take another picture, and then go, oh, there you go, that star has moved, that must be the asteroid. Or I can kind of human plate solve it by trying to match up my stellarium image with the image I'm seeing on the screen, all of which I found would be quite boring. So what I really wanted was the computer to tell me exactly where the asteroid was. AstroPlanner's calculations are good. I mean, it puts the asteroid somewhere in the middle here, but it's not good enough to actually put a cross exactly over where it is. And for that, we're using the JPL Horizons service, which is also an app, which let me show you. Here is the app. This is the app form of the API service we want, and this is 41 Daphne, and we are actually somewhere around 41 Daphne right now. There's also some other tools like the database lookup tool, which allows me to just type in 41 Daphne, and it will give me lots of information about Daphne. If I look at, it's got satellites, so it's actually got a satellite around it as well. When was it discovered? It was discovered in 1856. Closest approach data, things like that. The very impressive little orbit viewer. So we're seeing here that the Earth is here. Daphne is inclined relative to the rest of the solar system, as lots of asteroids are. And let's see what the orbit is from above, and we can see where Jupiter is as well. So the orbit is between Mars and Jupiter, gets quite close to Mars, spinning out. But right now, we've just gone past opposition with Daphne, so it's falling behind as we're catching up to see Mars. If I press the play forward button, you'll see how that works. So that's a really nice viewer that JPL give. So let's try out the script. So the first thing we need to do is we need to plate solve this view, and I'm just going to do that right now. So let's plate solve this particular view. It's done, and then I can bring up my deep sky annotation. Let me bring it over here. Actually, let's put it over here somewhere. And as you see, it's already marked off 2 galaxies that are within the shot. And it will also give me the nearby objects as well that I could go to. But it doesn't support asteroids yet, and it doesn't support comets yet. So for that, we're going to actually paste in a custom object, which we use here. So if I go back to my AstroPlanner and actually run my script, it will get the coordinates.
JPL query complete.
There you go. And I press the paste custom object info in, and there we go. Daphne is right in the center there of my crosshairs. In fact, if I live stack this, we will get a better result because the telescope's obviously shifting, or rather my telescope is obviously shifting. So if I then do another plate solve, there you go. So now Daphne is right in the middle of the crosshairs. So if I zoom in on Daphne for you, there she is there, and she's nearly 11 light minutes away now. When we first started looking at Daphne, she was a lot closer. She's 1.32 astronomical units away, and she's magnitude 10.85. It has to be said that Daphne's quite bright, and I can quite happily see that star here in stellarium is this star here. That star there is that star there. And Daphne, which is there, is in fact there. And that's because Daphne is very bright. But that's a good test, just so we know that we have got the right asteroid. Let's come out of here a second and we'll go to a different one. This is one we went to before, 3102 Croc. Now 3102 Croc's a lot fainter. It's a magnitude 16. So let's we'll save that as a FITS file, so we've got it as a thing. And we will find Croc, because I think I put Croc into the... I did. So I've put Croc already into AstroPlanner as an object I wanted to look at tonight, and I'm just going to, I think, if I've selected it or not, maybe I haven't selected it, I have. There you go, I'm a slew to Croc. Let's clear that, let's come out of the live stack a second, and take our zoom out. And we're approaching Croc, and we have arrived. If I just display stretch that. Now, let's do a let's put Croc's name up there. Let's do a live stack. Oh dear. Just clear that a second. Yeah, I wasn't sure if I was actually using the one of the old images. So let's play it off. And there you go, so those little ellipses moved and circles moved over to these galaxies. So let me find where Croc is then. So I'll ask the JPL Horizons web service.
JPL query complete.
Excellent, so where's Croc? Croc is right there. And Croc is a very faint dot right there currently at magnitude 16.11, but it's exactly in the middle of the crosshairs. What we do is we zoom in. And let's stretch the image a little bit to see if we can, we're going to, I think, pull that down so we can see Croc a little bit better. So it's quite hard to see. Croc is right in the middle where my cursor is now. You might be able to see it as a little dot, so I'll try to look at the preview. But there you go, again, exactly in the middle. And over here we have a 15.3 magnitude galaxy starting to appear there, an elliptical galaxy. And there's another galaxy over here, which is magnitude 16.5. But Croc, and the Croc is only 3.13 arc minutes away from us. 1.3 arc minutes, 3.13 light minutes away from us, or 0.38 AU. It's actually an asteroid that orbits inside, or comes within inside the orbit of Mars. So if we do 3102, and look at the viewer, then you'll see that currently we're quite close. It's actually quite a way above us, and it's coming down as we orbit along. If we look at it from above, we can see it comes inside the orbit of Mars. And the great thing about this is we can see when the next close approach is, and it will be on the 29th of August this year. And the reason for that is it's, even though the Earth is moving away from us, it's coming down towards us on the plane, not to where our plane is, shall I say. So again, this tool has got some very interesting features. When was it actually discovered? 1981. So there you go, Croc. So it's a rather interesting little script that just allows you to, in real time, which is what EA is kind of all about, identify what's actually inside your field of view because otherwise crop would have been quite hard, I think, to pattern match. In fact, yeah, it would have been quite. I think it would have been quite hard. You can see 2 stars up there. There are the 2 stars there. It's easier knowing it's there all the time. There's the 2 stars here, which is those 2 stars there, and I think, yeah, those 2 stars there. So as you see, it would have been quite hard to actually visualize where it actually is, and SharpCap just puts it, well, JPL, using AstroPlanner to find out the name, get the coordinates from JPL, and then just use the great deep sky annotation results to show where your asteroids are. So there you go. That is